we are going to show how to do principal component analysis in R. So for doing principal component analysis, we will use the package psych. So the R can do principal component analysis also in the stats package, which is installed with the base installation of R. But it's sort of awkward, so I would suggest that you use Psych for doing it. So besides Psych, we'll also use the tidyverse library as usual. What is a little bit different in this example that you might find in previous examples that I was making is this time I'm not using R Markdown, but instead I just use a regular R script. The reason for that being that R Markdown and Psych, especially for bigger data sets, they don't really collaborate very well. But nevertheless, so let's go to do this. We'll just do the diamonds example. So let's say we want to see what do we need to summarize data on the diamonds dataset. This is one of the datasets that comes with tidyverse. Actually comes within the ggplot2 package. So if we have a quick look at the diamonds, we can see it's a whole bunch of variables. So namely we have 10 different variables, but some of these variables are descriptive variables, and we can't really use descriptive variables for dimension reduction techniques. So first what we need is we need to form a subset of these data, selecting only the numerical ones. The numerical ones are, carrots and depth, table, price, and the general dimensions. Now we could select this by position or by names, or the easiest way, since we just need numerical ones, is that we use deployer and just use the numerical variables. So we select the data numeric. So we run this one and we get something called data, which is a subset of diamonds only containing numeric variables. Now the first tasks when doing principal component analysis is establish, so is the data even adequate for it? Are the correlations big enough? First off, we might establish, is there even any correlations going on? So is the correlation matrix not an identity matrix? And this is done by running the Bartlett test of sphericity. So if I run the test, well, you can see p-value down here, basically 0, an enormous chi-square. Data matrix is not a identity matrix, which, well, it was expected. This test has a very high power, so don't trust it too much. Anyways, so if I run the KMO, the overall KMO at 0.83, so KMO runs from 0 to 1, and the higher it is, the more suited the data is. So definitely for PCA it should be above 0.5, 0.83 looks was, we have solid data for it. Now if you look at the individual item, you might see the depth might actually not be the most suitable. The most suitable one, so maybe we should subset the data without the depth. So this command does it. So that's now the data. Maybe you can even look at the data now without the depth. So you only have these 6 variables. Describe is also part of Psych, gives you descriptive statistics. Descriptive statistics, you can see here at the standard deviations that one of the standard deviations is much higher than anything else, which points to the fact that we should definitely do the data using standardized data, so using correlation matrix, not covariance matrix. So if we rerun the KMO MSA overall measure of sampling adequacy, it's quite high, and all the variables look like they belong. The next question might be, so how many components will we need? There are several criteria for that. The best one is to run the parallel analysis. So this we need to run separately. Parallel is FA parallel. It's also part of the Psych package. We can run this one. We get a graph. You can see that, well, definitely we might want to extract one component, maybe two. Well, it doesn't have a suggestion for the number of components. It has a suggestion for number of factors 3. So we might as well do this analysis using just one factor. You can just use one factor, run this analysis, and yeah, with this one factor, you might see, well, everything is so the if you look at the communalities, so the H2, you can see that the table is not part of this model, whereas everything else is. So what we could try is increase this to 2. So we might be happy with this. So if you look at the analysis here, so if you look at the analysis, so with one factor we actually, so one component is sufficient. It even tells you that one component is sufficient. We were able to explain 80% of the variance with one component, but somehow, this table doesn't belong. But nevertheless, we have, this one component that we can call quality or size or value of the diamond, which incorporates everything from the size and as well as price, and we can use this in some further analysis. We might also export the scores and use them, so we might access them with this PCA1 scores. So it's one of the elements of the base. So this is the one, and you can see it's rather, maybe a little bit unusual numbers. The thing is, this is standardized scores, so negative values mean below average, whereas positive numbers mean above average. So essentially we have, smaller, less valuable diamonds here, and we have some much more valuables coming later on. We might even, draw this using a histogram or something like that. So this is how you do principal component analysis in R. Thank you for your attention.